Have you ever wondered how a simple flick of a switch can light up an entire room? It's a question that many of us take for granted, yet it's a process that's as fascinating as it is complex. At the heart of this magic lies the intriguing science of electricity generation. Just like a chef uses different ingredients to whip up a delicious meal, electricity can be generated from a variety of sources: coal, water, wind, and even nuclear energy. Each method comes with its own unique set of characteristics, benefits, and challenges. Some are affordable while others can be harmful. From the roaring coal factories to the silent wind turbines, from the thunderous waterfalls to the secretive nuclear plants, each contributes to the symphony of lights that illuminate our lives every day. Without further ado, join us as we embark on an electrifying journey to uncover the secrets of electricity generation. Let's begin our journey with the oldest and still widely used method of electricity generation: coal. This black, combustible sedimentary rock has been used for centuries to light up our homes and power our industries. But how does it all work? First, the coal is mined from the earth, in many cases from deep underground. Once it's brought to the surface, it's transported to a power plant where it's burned in a furnace. The heat from this combustion process turns water into steam in a boiler. This steam then drives a turbine which is connected to a generator. As the turbine spins, it generates electricity that is then sent to homes and businesses through a complex network of power lines. This process might sound straightforward, but it's not without its challenges. For starters, coal mining can be a dangerous job, with workers exposed to a variety of risks. Moreover, burning coal releases large amounts of carbon dioxide into the atmosphere, contributing to climate change. It also produces other pollutants that can harm air quality and public health. Despite these drawbacks, coal remains a key player in the global energy mix. Take South Africa, for example. This country relies heavily on coal for its electricity, with coal-fired power plants generating around 70% of the country's power supply. Why, you might ask? Well, coal is abundant and relatively cheap to extract and burn. This makes it an attractive option for countries with abundant coal reserves and a high demand for electricity. However, the world is changing, and so are our energy needs. As we grapple with the realities of climate change and the need for cleaner, more sustainable energy sources, the role of coal is being questioned. Many countries are now looking to phase out coal in favor of renewable energy sources, like wind and solar power. Coal has played a significant role in our energy production, but it's not without its downsides. As we move forward, it's important to balance our need for electricity with the need to protect our planet and ensure a sustainable future for all. Moving on from coal, let's venture into the world of renewable energy sources, water and wind. These two elements, as simple as they may seem, hold immense power, and when harnessed correctly, they can generate a significant amount of electricity. First, let's dive into hydroelectric power. Picture a vast dam holding back a massive body of water. When released, this water flows with great force, spinning a turbine connected to a generator. This kinetic energy of moving water is then converted into mechanical energy, and finally into electrical energy. Countries like China, Brazil, and Canada are leading the charge in hydroelectric power, showing us the true potential of our rivers and waterfalls. But while hydroelectric power is renewable and emits no greenhouse gases, it's not without its drawbacks. Dam construction can disrupt local ecosystems and displace communities, and the initial financial outlay can be quite steep. Now let's sail over to wind power. Imagine giant wind turbines, their blades spinning in the breeze. This is much like the workings of a hydroelectric power plant, but instead of water, we're using the wind. As the wind turns the turbine blades, a generator converts this mechanical energy into electricity. Countries like Denmark, Germany, and the United States are setting the pace in wind energy production. Wind turbines can be built on land or at sea, providing a versatile solution to our energy needs. However, like hydroelectric power, wind energy also has its challenges. Wind is unpredictable, and turbines can have a significant visual and noise impact on the landscape. Water and wind, two natural forces turned allies in our quest for sustainable energy. Each method has its pros and cons, but one thing is certain: these renewable sources of energy are key players in the global transition towards a cleaner, greener future. Now, let's delve into a more controversial source of power: nuclear energy. Imagine taming the very essence of the universe, the power harnessed from the heart of an atom. That's what we do when we generate electricity from nuclear energy. It all starts with a tiny particle, uranium. When this particle is split, a process known as nuclear fission, it releases a massive amount of heat. This heat is used to boil water, creating steam. And as you might have guessed, this steam then drives a turbine, which in turn generates electricity. It's a complex process with a simple goal: turning on your light switch. Now let's talk about the advantages and disadvantages of nuclear energy. On the positive side, nuclear power is incredibly efficient. A small amount of uranium can produce a vast amount of energy. It's also reliable. Unlike wind or solar power, nuclear energy isn't dependent on the weather. But nuclear power comes with its share of controversy. The main concern is the production of radioactive waste, which remains hazardous for thousands of years and requires careful management. There's also the risk of nuclear accidents. Although these are rare, their consequences can be devastating, as seen in Chernobyl and Fukushima. Despite these risks, some countries have embraced nuclear power. France, for instance, gets about 75% of its electricity from nuclear energy. The United States, too, relies heavily on nuclear power, with nearly 20% of its electricity coming from this source. It's a delicate balance, isn't it? On one hand, we have a source of power that can provide us with a substantial amount of energy. On the other hand, we have to grapple with the potential dangers and long-term implications of nuclear waste. Nuclear power, a formidable force that can either enlighten or obliterate. It's up to us to decide how we wield this power, with the hope that we always choose enlightenment over obliteration. With the sources uncovered, let's peek into the mechanics of turning raw materials into electricity. This magical transformation occurs in two main stages: the boiler and the turbine. Let's start with the boiler. Imagine a giant kettle, but instead of heating water for your afternoon tea, this one is designed to generate steam. Coal, water, wind, or nuclear power all heat water in the boiler to a superheated state. This means the water is so hot it transforms into steam. But this isn't your average sauna steam, it's steam with a mission. This steam, under high pressure, is then directed towards the turbine. If you've ever seen a windmill or a fan, you're already familiar with how a turbine looks. Now, picture this turbine on a much larger scale. The steam from our superboiler hits the blades of the turbine, causing it to spin. It's like blowing on a pinwheel, but instead of your breath, it's the steam doing the work. The spinning turbine is connected to a generator. Inside this generator, there's a magnet and a coil of wire. The turbine's motion causes the magnet to spin around the coil. This motion creates a magnetic field that pushes and pulls electrons in the coil. For those of you who remember your high school physics, this is Faraday's law of electromagnetic induction in action. The pushed and pulled electrons create an electric current, which is then sent down power lines to homes, schools, and businesses. It's this current that powers your refrigerator, your laptop, and the very device you're using to watch this video. And voila, that's how raw materials transform into the electricity that powers our daily lives. From a lump of coal, a gust of wind, a rush of water, or a nugget of uranium, we harness the power of nature and convert it into electricity. It's a testament to human ingenuity and our drive to illuminate the world around us. And that, dear viewers, is the journey your electricity takes before it reaches your light switch. Let's take a quick trip down memory lane, shall we? We've learned that electricity can be generated from a variety of sources. From the gritty coal mines of South Africa to the tranquil waterways and breezy hilltops harnessed for hydropower and wind energy. We've also ventured into the complex world of nuclear power, a source with immense potential, yet significant challenges. Each source carries its own set of pros and cons. Coal is affordable but harmful to the environment. Hydropower and wind energy are renewable and clean but dependent on the whims of Mother Nature. Nuclear power is incredibly efficient, but its waste poses a long-term challenge. We've also peeked inside the world of boilers and turbines, key players in the generation of electricity. Remember, every flick of a switch is a culmination of a fascinating journey. Before we wrap up, we have a light bulb moment for you. We've journeyed from coal mines to your light switch, and we hope you've enjoyed this electrifying ride. If you did, don't forget to like, comment, and share our content. We'd also love to hear your thoughts on power generation methods. Any bright ideas or shocking revelations? Stay curious, stay connected, and continue to illuminate your minds with us at Cognitive Crusade.